Good afternoon, everyone. Today, our first speaker is S. Rajesh, who is a journalist at Espncricinfo. He is a sports editor who has written various articles that have statistical insights. Today, he will be talking about whether we can quantify luck in cricket and how Espncricinfo came up with luck index and smart stats for T20s. Let's welcome him for today's talk.
Thanks a lot for the invite, first of all. Uh, I'm much more a cricket guy than a maths guy. So, first of all, I don't know what I'm doing here. But I guess after all the rigors and I don't know, how have your sessions been? Are they really intensive, or do they give you some sort of, yeah, I can see Dootika nodding vigorously. So yeah, so I guess this will be a bit of a break from some of those sessions that you had. And first of all, do you all follow cricket, or are you like cricket buffs? Uh, I, I need more hands to go up. I can see one there, but I need, yeah. So yeah, this talk will be might be a little heavy on cricket. It won't be very heavy on maths. But really, when Dootika and when Siva, thanks, sort of discussed this and said that, I mean, talk about something that you done which has a little bit of data along with the cricket. So this was the first thing that came to mind. At Espncricinfo, we developed something called Smart Stats and Luck Index about 5 years back, and we've been sort of working on it. It's been a bit of a work in progress. There have been some improvements that we've been trying to do. So I thought that that would be a good topic to sort of just discuss with you, and maybe even get more ideas from you guys as to what more we can do and how we can improve it further. So I'll just give you a short sort of a brief idea of how we got started. This actually didn't come from cricket. It came from football, and it was our sort of sister concern, ESPN.com, that did a series on football. So, well, this was in 2019 that ESPN.com did a thing with FA Cup football, and they decided to do something on luck index and luck in football, as to how do you measure luck events, what do you call luck, and then how do you put a value to it and say that what would have happened, or what would have been the game situation had luck not been part of the story or part of the scenario. So they did something like this in 2019 and said Man U big winners in luck index, and so the idea sort of originated from here, and it was used the following year, and our FD was sort of very impressed with this idea and said that, why don't you do something on cricket which would which would be of a similar ilk. And the first thing that came to our minds was, how do you even decide what these luck events are? And okay, yeah. So if those who are cricket buffs, what would you say are the lucky events in cricket? What are there any examples that you can give of a team getting lucky or a player getting lucky? Any thoughts? You would have seen catches getting dropped, umpires making incorrect decisions. Would that constitute luck? So what we did was that we identified certain events, because I mean, luck is too vast a sort of field, and it's too vague. You have to put specifics to it and say, what is luck? So we said, yeah, I mean, to start with, there are things like a catch gets dropped. So what we normally say is that the batter is lucky. He should have been out for 5. He's gone on to score 50. So so those 45 runs he's got are the lucky runs. So in that way, we sort of try to identify what are the events that that would constitute luck. So to start with, we sort of try to identify what are the events that we have to consider. So broadly speaking, what we tried to do was, there were two separate sets of events. One is something that is just for a ball and it doesn't impact the rest of the game, or it impacts it in a very small measure. So those are non-dismissal related, a single ball like a no ball or a wide, which we then decided not to give too much importance to because that was a single ball event. The major events that we thought is something like a dismissal related, where a player should have got out and didn't, or a player should not have got out and he did. So in that sense, we have dismissal related. So suppose there's a catch that is dropped. So you say a player should have been out, of the first ball that he faced, but he wasn't. The catch was dropped. He went on to score 60 runs of 40 balls, and that changed the complexion of the game. So there were a couple of things here. So one thing was, how do you identify what was the value of that luck to the team? Now you can say the player got 40 extra runs from that. But the other question was that if he had not batted, someone else would have come in and he would have scored either some of the runs or all of the runs. So our problem was a little more nuanced in that sense. It's not just that the player gets 40 runs and hence the team benefits by that much. It is that how much is the team benefiting by actually, because it's a game of 11 players and several batters. So if he gets out, someone else comes in and gets a certain number of runs off those many balls. So for us, the issue was how to find out what is the incremental number of runs that the player has got because of that lucky factor. And the other thing was that for the fielding team, we had to sort of also decide what is a lucky event and what is a skill-based event. That was again something that this covered the. So yeah, what is a lucky? So in this, there are two again in the dismissal-related events. There's a replacement event, which is dropped catch. A replacement is where a player should have been out and wasn't. And the reinstatement is where the player was out but shouldn't have been. So what we are essentially doing here is that in the replacement event, we are replacing the batter by the next players. So that was the theory we built our sort of framework on. The reinstatement events were where a batter was given out, but he is wrongly given out. So we put him back on the field and we create an alternate scenario of how many runs he would have scored had he not been given out. So those were the two sort of essential differences and the two scenarios that we created in order to sort of figure out how many runs would have. Yeah, this is an interesting concept of zero sum. So you can say that, batter's catch was dropped, he scored 60 runs. So the batting team was benefited by a certain value. But can you again say that the bowling team suffered by that many runs because of luck? So there we had a debate, and so we worked on this with IIT Chennai. So we had professors and a set of good students there who worked with us. And the argument was that, it should be zero sum. So if you're gaining luck, then some team should be losing luck. But then there's also a cricketing context to it, which is why I come back to the cricket part of it. That if a fielder drops a catch, it is not really luck, it is a skill factor. So we differentiate between what was luck and what is skill. So for the batter, he should have been out. It's just sheer chance that he didn't get out. But for the fielding team, it was a skill-related event where they didn't execute as they should have, and hence they lost out. So we said that it should not be a zero-sum game. There should be one team that wins or gets luck, and the other team is a skill-related factor. So there should not be a luck event related to that. So in that sense, then we came up with this sort of grid where we had to then identify events and then figure out how it looks like on the luck grid matrix. So if a batter is affected by a catch drop, he is. So that is, we mark a Y for that to say that he is impacted by that event in terms of luck. In the last column, we see the bowling team is not impacted. They are impacted in the match, of course, but it is not a lucky event for them because we said it is skill-based. So we did not give a luck factor to that. So we created a grid like that. And then we had a separate, our scoring team went into like each ball and marked all of this for every luck event that happened in terms of whether a batter was affected, whether the bowling team was affected, whether the batting team was. In case this looks a little complicated, shout and let me know. So once this, yeah.
The -1.
Batsman not out. No, ignore that. I think that was the umpire's call was also taken as no. Yeah, yeah. Yeah. So now that we had this grid in place, then we said ki chalo we need to put a number to it also. So how do we come up with a number saying that this was the value of the lucky event? So what we did was that if it's a drop catch and a player should have been dismissed and wasn't, so we ran a simulation, an alternate situation where the batter gets out and he's replaced by the next player coming in. And then the game goes on from there. And a certain number of runs is scored by the team with this alternate scenario, as opposed to the actual scenario of a player batting there, staying on and scoring whatever number of runs he did. So at the end of the innings, there is a difference between how many runs the team scored in situation A, which was the actual game, and in situation B, when he was replaced by another player, and then the game went ahead. So in that situation, we said that the difference between the actual and the simulated score is what is the value of the luck. So it's not just the number of extra runs that a player has scored. It is the difference between what is the actual score of the team in situation A, which is the real situation, and situation B, when he is which is the simulator, when he's replaced and there's a new player coming in. So so once that was done, it was sort of possible to get a value to it and say that this is the value or this is the luck value for that event or that catch. So if you then sum it up for all the events in an innings, you get the total luck matrix or luck factor for the team, and similarly for the tournament and so on. So the last line was something interesting that we found, that sometimes if a really poor batter is batting, and I mean, you could take examples of, say, Rahane batting on after the power play, and scoring at a runner ball, or any of the equivalents that you want. And sometimes we say that that catch shouldn't have been taken. You should have dropped him and allowed him to continue because he's scoring so slowly. And since especially in a T20 game, you have only 120 balls, and that is your real crunch. You need to maximize runs of every ball. So the more you waste balls and the more you allow a poor batter to stay on, you're actually helping the fielding team. So you would often say that, ye catch kyun liya, you should have dropped that. And, you should have allowed that player to play on. And instead of that, you have a Russell coming in, or you have a better player coming in, and taking that wicket actually hurts the team, hurts the bowling team more than the batting team. So it could happen also in such cases where dropping a catch is actually helped the bowling team more than it has the batting team. So those were the sort of factors and nuances that were considered. And so this had gone through. So the replacement value of a player is not just the total that he scored after the catch was dropped or after the event happened. It was what would have happened if the other players had also come in and scored whatever runs they had of the remaining balls. So this was so we developed content like this around Luck Index. So this was a game which was RCB versus, okay, if I'm not connected here. So yeah, so we could come up with content like this saying that, in a particular game, this should work with the link, but I don't think the internet connection is working here. Okay, I think the Wi-Fi has dropped out. Anyway, I'll share this with you later. You can take a look. So what we did was you could come up with content like this saying that No, the dropped catch when Dinesh Karthik in this case was dropped on a certain score, he went on to get 61, and had the catch been taken, they would have finished on 163 instead of 189, which they would have scored. So in these cases, there was one interesting thing when we also presented this at the time of launch in Bombay. We had also Rahul Dravid and Sanjay Manjrekar at the launch, and we presented smart stats, and we sort of showed them this matrix, and there were a couple of interesting observations there as well. With this sort of thing, what we also did was then we could see if the event has actually caused the team if the result to change. If a team would have won or the team would have lost had this event not happened. So what we sort of did is that we have a 26-run margin here. And if the actual result of the match was less than 26, you could argue that, had this event not happened, then the result would have flipped. So instead of RCB winning the match, they would have actually lost the match had this catch been taken. So that is the kind of storyline that we tried to build. There was also an interesting alternative view to that came up from, I think, from Rahul himself, is that the approach of the team will change. A team that is batting second or chasing, depending on the target. So if the target is 189 or 190 or 200, versus if the target is 160, the way they approach the innings, the way they plan would have changed. So is it fair to say that, that this gap itself is the reason, or can we say that the result would have flipped had this event not happened? Because of the team's sort of difference in approach when they know what they have to face. So if they are going after 200, they may just start very aggressively and they may get bowled out for 140 itself, in which case they may not even chase 160. But in the other case, if you have a target and if you know that you're only chasing 160, your approach would be different. You would sort of pace your innings better, and you may get to 160 knowing that that is the target. So that was an interesting alternate view. But what we did was we went with this sort of approach, saying that this is the difference and this is the value of the luck index. So this is a similar one for this was for the WPL game from this year, which is again, this was UP Warriors in Delhi. Yeah. So again, this was a big difference of 37 runs between what would have happened had the catch been taken versus when it was dropped. So these were some of the storylines, and in all of this, the big question is that you get these values of scores, but how do you actually come up with these scores? Because that's at the crux of the whole problem and the whole framework that we have made. That if you have a certain event, you need to also calculate how many runs are scored at the end of the innings. So how do you do that? So for that, and basically this was at the fulcrum or the base of all the different metrics that we came up with. This is our forecaster, which is saying that at every stage of the innings, where does a team end up with at the end of the innings? So if you're starting at 0.0 or 0.1 overs, what is based on the teams, based on the conditions, based on strength of each batting and bowling unit, what is the final score that a team will end up with? So that is again something that, for people who play fantasy cricket or people who sort of make teams, it's something that they always look for. Who are the guys who are going to be the star performers today? Which team is going to win? Who's going to be your man of the match? And so this we came up with, called our forecaster, based on team strengths, based on the batting and bowling strengths, based on several other factors, to say that at any stage of the innings, what is your final score going to be like? So this was where we sort of spent most of our time and most of our sort of, even with Professor Rangaswamy from IIT Chennai, that the major factors that the forecaster, what it should take into account, what it can leave out, and how do we come up with the framework and the mathematics behind it, which I'll not go into in too much detail. So these were the factors that we looked at. the quality of the batting and bowling attacks, the strike rates, there are different phases of it that we need to go into, the power play, middle overs, and the death overs, how the playing style changes, how the batting strike rates change, uh, what are the venue averages. The venue averages, again, were a bit tricky because venues change all the time. I mean, a pitch that was playing in a certain way maybe 3 days back or a week back may not play the same way today. There are different pitches that teams play on in different matches. And then if you go into more detail, there is black soil and there is red soil, and the surface changes, the conditions change with every game. So there are issues, but for the matter of just taking a mean value, we had to go with certain sort of venue characteristics and putting them into a bucket and saying that these venues have similar characteristics. So these will be treated as one bucket. And so we made 3 different buckets saying that these are 3 broad characteristics of venues, and hence they should be sort of slotted into those buckets. But also then the venue thing is a historical data. To come into current match context, it also has to be nimble enough to know that, in today's match, the situation is different and teams are playing differently, conditions are different. So it needs to take in the conditions from today's game as the game goes along. So that also came in to say current match situations in terms of how easy or how tough. So based on past player records and their deviation from today's match, there's a factor there. So that factor gets applied to the rest of the batters or bowlers who are coming into play in the match. And hence then we also take into account the current game conditions as well as the historical factors. So those were, so all of that, it needed a lot of tweaking and fine tuning and back and forth. And so our job in the whole exercise was to look at the matches and data that our team from IIT would run and give it to us. And we would then check at every phase of the match, at every stage, and say that this looks okay, but this doesn't look okay. So then we go into why this is not looking okay. What would we like it to be? And sometimes what we like it to be is a vague sort of, it's not necessarily built on data, but it's also on years of watching cricket and just knowing as cricket fans what you would expect to be a reasonable score. So from there, we would look into factors which go into the algorithm and what needs to be tweaked, and then come back and run some of those matches and see how is the result looking now. So there was a lot of iteration, a lot of back and forth, and which was very, very intensive and time consuming, but also very rewarding in terms of what we came up with in the end. So yeah, so broadly, this is what we sort of decided that the forecaster would take into account. So what it did was at every stage, it would allocate a certain number of balls to every batter who was to come in to bat, and it would allocate a certain number of overs to the key bowlers who are supposed to bowl, and then do a matchup between the two and come up with an expected strike rate for the batter and for the team, and then say that if a batter has 10 balls to face, he is likely to score 16 runs, and those 16 runs gets added to the total. There is also an extras component, and similarly for the bowling team, and then we come up with a total number of runs scored. So this is the forecaster. What we did was then plot a graph for at each point of this was the IPL final which happened last week. So if you can see here, this was when RCB had scored 190. So this is the second innings plot for Punjab chasing it. So when they started the innings, 190, again, there is a change because we have taken data from the last couple of years when, if you followed IPL and in general T20 cricket, you'd know that scoring rates are going up. So what used to be a par score maybe 2 years back or 3 years back is no longer the par score because it has moved up. And so in this case, this was a game in Ahmedabad where RCB had scored 190, which was the lowest score of that season at that venue. And teams were regularly scoring 200 at that ground. So despite a score of 190, we saw that Punjab, when they started chasing it, their win probability was about 56, which you see is slightly above 50 there. So they started with a slightly above par chance of winning. And despite chasing a total which looks to be on the higher side historically, that's because of venue conditions and how the forecaster was sort of nimble enough to say that conditions have changed and the format has changed. So 190 is no longer par, it's a little below par. So that's how it started. And but then as we go along, we are also marking the wickets that fell at each stage and how the sort of win probability kept dropping all the way. There was only a marginal spike towards over number 16, 17, and then how it finally sort of petered away into a win for RCB. So that was so in these cases, sometimes you can also, this is a similar thing for the WPL final that happened this year. So in these cases, you can see there's a spike that goes up at almost 50. And in this case, the score that they were chasing, this was MI batting first and Delhi Capitals chasing. This was a score of 150 that they needed to win. So in women's cricket, the scores are generally lower. So the win probability at the start is almost the same as, I mean, just coincidentally, it's almost the same as in the men's IPL final. But the score they were chasing was 150 as opposed to 190 in the men's game. So it's also a difference because of the change in, because of the different scores between women's cricket and men's cricket. So even here they began with a win probability of almost about 57. And then it gradually came down and there was a spike around, yeah, around 16, it went up to 50. And yeah, if you check the scorecard, you'll sort of, so this is also a good way to know the turning points of the match. So where is it that a game turned if there is a drop in the forecaster or a sudden lift in an over when maybe 20 runs were scored. So you will suddenly see the forecaster go up from about 35 to 60% or 65%. And so you know that that was the over where the match turned, or that was the one of the turning points of the match. So those are key moments when you can actually say that the game turned there. So here just a little bit about how those batting rates and how the calculations were done for for predicting how fast a batter will score or what will be his strike rates. So it wasn't just historical data, but it was also based on the current innings and how he's going in that innings. And depending on that deviation between his historical data and the current innings, so that learning was incorporated into the subsequent balls that a player faces. So in that aspect, I mean, we try to keep it nimble in terms of the algorithm also learning from the current match and not just relying on historical data to make all the predictions and all the forecasts. So, so along with the forecaster and the luck, there was a third factor that uh, I think, Dootika, you had also what you had started with in 2010 when you said you wanted to do a rating for players. This sort of looks at that. We decided that since we are doing a forecaster and looking at players and how much they are deviating from what should be the norm, that will also give us a sort of rating thing in terms of each performance, whether it be batting or bowling. We can see that what was more or less par and how much did they contribute in terms of the team getting to what they did in terms of either the runs scored or in terms of the economy rates and the wickets. So here we look at in every batting and bowling performance, and not just in terms of broad numbers, but actually looking at the actual required rate at that point, how many wickets the team had lost, who are the batters to follow, what was the kind of support he got. So this was what we did was at every stage there was a pressure index created for each batter and bowler. So as you know, when a team is batting or chasing a target, depending on the asking rate and the current run rate that they are at, You'll hear commentators say that, these batters are under a lot of pressure. The asking rate has gone up to 12. The current rate is only 8. They have only 4 wickets in hand. So these are again nebulous, vague terms that you say, but we sort of put a value to it. We put a numerical value to pressure at every ball by saying that compared to the required rate, where are they currently? And where is who are the other batters to follow? Who are the other bowlers in the opposition team who are likely to bowl? So at every point, we created a pressure index sort of thing by removing that player from the team and saying that how much will the team score if that player is not batting. So that gave us a good indicator of how important that player is to the whole team. So that gave us a sort of pressure component based on which every run he scored or every wicket that he took was weighted against that pressure, and we came up with a value at every ball level. So that's how we sort of came up with this is what I explained just now. So at every ball, we would say what is the pressure on the particular batter bowler. So every run he scores or every dot ball he bowls is weighted against that. So it's possible that a player scores a boundary, scores 4 runs, but it would be valued at say 6 or 6.5. So similarly, if a bowler bowls a dot, it might count as a -1 or a -2 against his name. So, or if he goes for a 6, it might count for a 9. So that was the way we sort of came up with smart stats, which gives you a value of every run scored or every wicket taken. This is one of my favorite examples to sort of show how the system worked. There were 2 matches here. This was in the 22 season, and thanks to Rahul for giving us such an example, because without 2 such very similar innings, I don't think we would have had such an elegant example to give you the variation between. So he scored in one game again, it was against the same team and the same bowling attack. He scored 103 of 60 in one game and 103 of 62 in the other. So you would think that they were very similar innings against very similar bowling attacks. But in one case, our impact point system rated it at 115. In the other case, it rated it at 168 almost. So the difference is in the contribution of other players compared to him. So in one case, you had other players scoring very well also. So the others got 88 of 60. Others got 88 of 60 from from the team, and from the opposition in the entire match, they scored 254 of 180. So if you look at the strike rates, they are going at almost 145 to 150. Whereas in the other game, they are going at barely 100. Whereas Rahul's strike rate remains the same at 165 plus. So the point being that when one player has done so much better than the others in the match, then it clearly means that he has outperformed and he has been by far the outlier compared to the others in the match. So if you look at the strike rate ratios of 1.7 compared to 1.2, roughly, so we had something called the impact runs and the points. So if you look at the points, the difference is 50 or more than 50 in this case for the same number of runs at almost the same. In fact, he played 2 more balls in the Wankhede innings where he got more impact points. So the idea was that if you do very well in difficult conditions where others are not doing well, then you need a system that rewards you more, because otherwise, especially in T20 cricket, you have a big range of scores. Team can score 140, they can also score 240. So how do you differentiate between a player who has scored 70 of 50 balls in both innings? So this was a good example in a real match situation where we actually got numbers that brought out this contrast in the same season against the same opposition. It brought it out very clearly. And these are values that we come up with on a every match by match basis. This was from the WPL final of this year. So at every match level, we have, again, by being able to equate batting and bowling performances, we have sort of impact points which you can compare batting and bowling, and we have a match-wise impact list. So while the team or the tournament will have their own man of the match and man of the series awards, we have our own here through the impact ratings. And in this particular case, you see that Delhi actually lost the match to Mumbai in the final. But the player with the maximum impact points was from the losing team. This is arguable. Many of you will say that, how can the losing team have a player with the maximum impact points? But sometimes it does happen that in terms of the game itself, the most significant and strongest performance has come from the player of the team which has lost. So in this case, there was Marizan Cap who got 40 of 26 and 2 for 11 of 4 overs. So economy rate of under 3 and over. In this case, according to Smart Stats, even though we give a certain boost to the winning team, despite that, her value of impact points was more than the winning, though the next 4 were all from the winning team. So, I mean, the argument, of course, is that you don't win with just one player doing well, you win with the whole team doing well. So, in this case, Mumbai's players, the other players did much better than the rest of the Delhi team, which is why we got the result we did. But you can see in terms of consistency of performances that Mumbai had 4 players with more than 50 points. Delhi had only one. So, but it does happen that a player from the losing team, if they have put in an outstanding performance, they can top the list as well. So this you can extend into a series, you can extend into a year, you can extend into whatever time period you want, and you get the sort of rating that you had initially come up with Dootika and way back in 2010. But yeah, this, of course, this also takes a lot of ball by ball data, which at that time would not have been available to. So what we have tried to do is then to tweak it to sort of make it better with every passing year, season. I mean, there are constraints in terms of how much time we have to work with these factors because we are on ball by ball and we are on sort of cricket duty through the year for other matches. So this sort of a project is like a sort of long drawn out and it's something that we would love to do more of. But then there's also the regular cricket that comes in the way. But wherever possible, we have tried to improve this, and I think we are at a fairly good stage with this in terms of the numbers and what they look like. But in terms of if you have any further questions or there was also the reading that I had shared with you, Dootika. Maybe you can share it with the group as well. So in terms of it was we had to do this in about 3 months when we started this, and from scratch. So it was a fun project to do, and we left most of the match to the experts, but we were there in terms of cricketing sense and giving them some sort of our points of view about what makes sense, what doesn't. So it was a mix of hard data and sort of qualitative inputs where you don't always have data to back it up. So in that sense, it was an interesting mix of the two. And we are happy with the final product that we have here. But yeah, there's always room for improvement. So if you guys have any questions or any observations.
In the beginning of the presentation, you talked about this ill luck and the lack of execution, right? So I wanted to know, how do you draw the line between ill luck and this lack of execution? Like, for example, a batter's ball getting dropped cannot be just lack of execution from their side or just ill luck from the batter's side. It can also be like the way the ball went was in such a way that the person could not catch it or something like that. So how do you draw the line between them?
So in this case, the term catch is a dropped catch is defined only if the catcher had a chance to take the catch. So if it was out of reach or if it was very difficult or if he just got a fingertip to it, then we don't define that as a catch. So in that case, it is not marked as a luck dismissal event at all. So it is only marked as a luck event if it was catchable and the fielder had a fair chance to catch it. Fair chance is, I agree, a little subjective, but that's how we define it. We have a tough catch and a easy catch sort of classification as well. But once we define that as a catchable chance, it goes as luck for the batter. And I mean, it's a skill thing for the fielding team because it was an event that it was a catch that should have been taken. The batter should have been dismissed. So it wasn't bad luck that the fielder dropped it. It was poor execution. That is just how we define it. It's still bad luck for the bowler. So when we do a bowler classification, it would still classify as a wicket that the bowler should have got, but he didn't get because he didn't get the assistance from the fielder. But in terms of the team outlook, it still goes as a skill that was not executed as it should have. So they don't get that that benefit of luck for that event.
Any more questions?
Audible. Okay, sorry. So the kind of statistics you were talking about, right? So is probably of interest, like for reporting out the match that has just happened. Like, are there things that you have internally, or like have you been asked to like kind of model things that could be of interest to a team, like for their training purposes?
Not specifically, because to start with, as a company, ESPN was not associated or linked to any team. We keep ourselves neutral, and we don't sort of associate ourselves with a team. So that's to start with. So I mean, there have been discussions, and I mean, I was part of that, whether we should do stuff for teams, because a lot of data analytics companies do that now, because they join with a team, and I mean, each team has a data analytics. In fact, one of my colleagues has now joined Sunrisers Hyderabad, and he's their team analyst now. So, and they do use a lot of specific data. What they use a lot of is video data, though. We don't have access to all the video data. So they actually use video data, and then they tag it specifically, and then they use that for further analysis. So what they can do is they can actually tag for specific ball speeds, specific bounce. So if you want to know 6 to 8 meters bounce at 140 kilometers per hour, bouncing at a certain height, you can tag and you can get a list of all such deliveries. And then you can see how Shreyas Iyer has performed against that every ball. You get a video of that. And then you can see how he used to do 6 months back against those specific deliveries and how he's doing today and has been. And so all of that comes in. I mean, there are a lot of specific analytics that happen. But one, we don't have access to all the video and that data. And the second thing is that we don't align with specific teams. So yeah. But a lot of this can also be useful for teams in terms of.
Does anyone have questions?
It was, we initially started with sort of RNN, and it did not really give us the results that we wanted. We had a few iterations with that, and it would throw up things that we couldn't understand either. And then type was a factor, and we were not sure if, and it was a very tight factor because we started the project around November, and by Feb or early March, we needed to wind up, and we needed a product for the IPL. So we were getting results that we couldn't really make sense of, and here we need to explain the results. So as I mean, once we get the outputs and IIT or whoever we are working with, then we are the front end for the readers. So we need to explain why this is showing this and that is showing that. So we were getting results that at that stage we could not explain, and we did a few iterations with RNN, it didn't work. So it was then more like a linear sort of yeah.
So you mentioned many luck factors, and why is toss not mentioned? Like in some weather conditions, batting first will be easy to win. So why is toss not mentioned in the luck factors?
Toss could be one, but it was difficult to separate the difference between a team batting first and a team chasing. in terms of numbers, that how much a team would score batting first and how much a team would score chasing, whether from historical data, whether that would also apply for the current game. It was difficult to accurately gauge that, because I get your point that some venues are very favorable to team batting first or to team chasing, or the dew. Well, the dew, for instance, is a big factor. But on that particular day, whether it'll happen or not, and there are some of those factors which we couldn't very accurately figure out, or at least put a numerical value to it. So we decided to just keep it to events that happen once the match starts and after the toss is done. But it's a factor that could be analyzed further. I agree.
Thank you so much.
Let's thank the speaker for this wonderful talk.
Thank you.